Students, today we will learn the chapter Binomial Theorem. And this theorem will be studied into two parts. One is for positive integral index. Okay, and second is for any index. And in this part we will learn about positive integral index. In this next part we will learn about any index. So what is the binomial theorem? Before going to express it, I will required to describe something. In permutation and combination chapter, you have know the meaning about this. Factorial n upon factorial r, factorial n minus r. And in this chapter, what is the meaning of ncr? The meaning is that from any different object, you have to select r different object. You remember this? And what is the meaning of the factorial n minus 1, n minus 2, dash 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 4 3 2 1? And using this formula, what will be required? The formula, open it and you know the formula n minus 1, n minus 2, n minus 3, and if it is r, n minus r minus 1 upon factorial r. Okay, so the meaning of this, from n different object you have to select the r different object using this formula. If you don't know this formula in detail, so you should be learn in the chapter permutation and combination. Okay, next I want to tell you one very important result. Look here, 11 to the power 0, and you know the value of this is 1. The power of any digit is 0, then its value is 1. Now 11 to the power 1, so that is 1 1. 11 to the power 2, you multiplied, you know this value is 1 2 1. And 11 to the power 3, when you multiplied it 121 by 11, you will be get 1 3 3 1. Similarly, 11 to the power 4, what you will learn, that is 1 4 6 4 1. Similarly, 11 to the power 5, you will get 1 5 10 10 5 1. Now check here. Here is a very important triangle, and you can see here is a very important triangle. This one is a triangle, and you can see the resultant is, when we add this 1 to 1 we get 2, and similarly when we add this we get 3, and add this we get 3, add this we get 4, 6 and 4, and when we add this we get 10 here also and here also. This way you can write again the 11 to the power 6, 11 to the power 7, and this triangle is very important triangle, and this we will use to explain the binomial theorem. Okay, and this triangle is known as Pascal's triangle. How I have described this triangle, have you understand this? So you can write 11 to the power 6 again and again, 11 to the power 7 and so on. Now third point I will tell you now. You can see here if you multiplied x plus a to the power 0 means it is 1, and x plus a to the power 1 you will get 1x plus 1a, and x plus a to the power 2 you will get 1x square plus 2x a plus 1a square. And you know the factors x plus a square plus b square plus 2ab in the 10th class, you have previous class you already studied. Similarly for x plus a to the power 3 we will get 1x cube plus 3x square a plus 3x a square plus 1a cube. Now you can see what I have described in the previous triangle here. You can see 1 1 1 1 2 1 1 3 3 1. So you can see here you can see here 1 1 1 1 2 1 1 3 3 1, isn't it? Okay, again you can check here 1 3 3 1, right? So if you want to write power 4 1 4 6 4 1, so you can write directly x plus a to the power 4 1 x to the power 4, add this you will get plus 6, and add this you will get 6, add this you will get 4 and 1. Power 4, you can see power of x is decreasing here. Power of x is decreasing at 3 2 1, and here power of x is 0, and power of a is increasing, a to the power 0, a to the power 1, a square and a cube. So you can write here x cube x square x to the power 0, and you can write here a to the power 0 to the power 1, a square, a cube and a to the power 4, and you can write here plus. So this way you can write x plus a to the power 4 in very easy way. Okay, now you can see the power of first term is decreasing and power of second term is increasing. So you can evaluate of any power of this, but it's a very large process. If you want to be describe x plus to the power of n, so this is a very long process. Okay, so this is described by binomial in a very short manner, that is known as the binomial series. These are two terms x plus a, so it is binomial, and this is the expansion. This expansion is a series, and this is phenomena is known as binomial theorem. So if you want to be described of the power of n, okay, so you have to learn the binomial series, right? Now the value of this coefficient, you can see here, we can describe it by nc0, nc1, nc2, nc so on. So now you can see, if we are taking the value of x plus a to the power 3, we have right here 1 x cube plus 3x square a plus 3x a square plus 1 x cube. Now what is this coefficient value of this? We can write here, this we can take an n, okay, so it is 3c0, it is 3c1, it is 3c2, it is 3c3. So using this formula nc0, when we find the value of 3c0, we will get 1. 3c1, we can find the value of this using this formula, okay, just I am going to detail in n minus 1, n minus 2 upon factorial 1. What is the formula then? It is equal to 3 upon factorial 1 equal to 3. 3c2, that is we can 2 factors n minus 1 upon factorial 2, 3 minus 1 upon 2 into 1. So we can get here 3, and again 3c3, okay, so we can get n minus 1, n minus 2, 3 factor, if 3 factor upon factorial 3, and using here 3 minus 1, 3 minus 2 upon factorial 3, we get 1. So we can describe this coefficient by this is also, okay, right? So binomial has described about nc1, nc2, ncn. How this we are going to be understand, right? Now you can see here, if we multiplied x plus a1, x plus a2, what is the result here? The result is x square plus a1 plus a2 plus a1 a2 x here also. Now you can see here x1 a1, x plus a2, x plus a3, when we multiplied it this one, what we get here? We get here x cube plus a1 plus a2 plus a3 x square, and plus a1 a2 plus a2 a3 plus a3 a1 x plus a1 a2 a3. So you can see here, students, these are 3 factors. Then we can see here is the sum of all factors by multiplied each by 1, sum of all factors, and is multiplied by taken 2 factors, and here taken 3 factors, right? So a1 a2 a3 we have select here 0 factors, and we have selected 1 vectors. We are selected here 3 times 3 factors, and we are selected here 3 vectors. So we can write here, we can understand this. We have selected 3c0, and from here we can write 3c1, and from here we can write 3c2, and from here we can see 3. If there are 3 roots a1 a2 a3, we can understand we are writing here from a1 a2 a3 3 members. We have selected no one, 0 we have selected 1, and we have selected 2, and we have selected 3. Okay student, Are you understanding? Now let us we say if a1 equal to let's say a1 equal to a2 equal to 3, then what happened here? We can get here x plus a, x plus, let it is equal to a, x plus a, x plus a, x plus a. Okay, we can write it add x plus a whole cube in LHS. Okay student, so now what about the RHS? a plus a 3 times, how many times? 3c1 times, means up to 3c1 term, so total is 3c1a. okay, now this one is a into a plus a into a plus a into a, it means a square plus a square plus a square up to 3c2, so it is 3c2a square. Similarly here we can write here 3c3a cube. Okay, so a into a up to 3c3, so we can write here 3c3a cube. Okay, so student, now using this we can write this RHS this way: x plus a whole cube is equal to 3c0 x cube plus 3c1 a x square plus 3c2 a square x plus 3c3 a to the power 0 means x cube. Okay, a cube x to the power 0. So now you can see here this 3c0, 3c1, 3c2, c3 we are describing here, and x cube, x square, and x the power is reducing, and the power of a is from 0, 1, 2, 3 and so on. This is the expansion of binomial theorem. Okay student, are you understanding? So now we can say what is the binomial theorem. We can write now binomial theorem in this way. For the power of n, we can write the first term this way, nc0, and x to the power we can write n minus 0 and a to the power 0. Now you can see here for 3 nc0 means 3c0, this is the first term, and x to the power 3 minus 0 you can see 3 here, and a to the power 0 means 1 you can see here. Now what is the next term? That is nc1 x to the power n minus 1 a to the power 1. So you can check here student, next term we can write nc2 x to the power n minus 2 a to the power 2 and so on. Now we can write a general term, let plus ncr x to the power n minus r a to the power r, and the last term that is ncn x to the power n minus n means 0. Here you can see power of x is 0, so we can write a to the power n. Now you can see power of a is increasing and power of x is decreasing. So this is the binomial theorem. Okay student, now this value, these digits are known as coefficient, and this is the series, and these are the coefficient. Okay, the digits are the coefficient of x, x square, x cube and so on. Right, and the others are, and then you can write the series. Okay student, are you understanding? Now I want to be described it now you can be prove this series by mathematical injections. You can prove this by mathematical injections. Okay, so I want to be described these questions. Prove binomial theorem. Prove binomial theorem by principle of mathematical induction. What is the principle of mathematical induction? If you don't know this chapter, first you go to this chapter. In the video I have explained it. Okay, so let us we have to prove a Sn statement, that is x plus a to the power n, x to the power n plus nc1 x to the power n minus 1 a plus nc2 x to the power n minus 2 a square dash 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 plus ncn x to the power n minus n a to the power n. Okay, so regarding this what we have to prove in this but PMI, how we can prove it? You know that first we put the value n equal to 1 both side, and then we can check it, then we write for check for r terms, then we can check for r plus 1. I remember this. So first we can check S1. So LHS x plus a to the power 1, we will find here x plus a. Okay, now RHS we can write here for 1 x to the power 1, right, plus 1c1 x to the power 1 minus what is 0 a to the power 1. So we stop it, right? You can see n. Okay, so value of this is x plus 1c1 is 1, it is x to the power 0 a, and x plus 1 it is 1, it is a, so x plus a equal to LHS, hence S1 is true, right student? Okay, now let it is true for r. Let SR is true, then we can write x plus a to the power r is rc0 plus rc1 x to the power r plus nc let for it is k, it is more suitable. kc0, okay, then kc1 x to the power k minus 1 a plus kc2 x to the power k minus 2 a square dash dash dash, and the this one is the last term k and x to the power k minus k and a to the power k, and this one term is previous term is k minus 1 x to the power k minus 1 a to the power k minus 1. Now we have to prove for sk plus 1. So we can see if we multiply both sides by x plus a in SR, so what we get LHS is x plus a to the power k into x plus a, we get x plus a to the power k plus 1. Okay, in RHS if we multiply it by x, then we get x plus a. Now we can get to multiplied by x plus a. What we get here, let we multiply it by first x, then we can find x kc0 x to the power k plus 1 plus kc1 x to the power k a plus kc2 x to the power k minus 1 a square dash 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 plus k minus 1 x to the power k minus 1 plus 1 a to the power k plus 1 plus k x to the power k minus k plus 1 a to the power k, and then if we multiplied by a, so what we get here plus, and this you have to write not multiplied here but you write this way, so kc0 x to the power k a. Now I am multiplying by a. This is the product of x and this is the product of a. Okay, and you can see, write this term here. Now multiplied by a in this term, what we get here, kc1 x to the power k minus 1 a square. So use this term. Okay, similarly we can finding the next term, this one here, k minus 1 x to the power k minus 1 a to the power k minus k, and then at the last what we get here, k x to the power k minus k a to the power k plus 1, and we can see we will add this term to this term, this term to this term, and so on, and the last term we left it, we add there this way. So what we get here, now you can see, you can take the common x to the power ka. What we left here, kc1 plus kc0, and we take the common x to the power k minus 1a square. What we left here, you can see here, kc2 plus kc1. So next term what will be, first term this, second term adding this, third term adding this, and this will the last term, previous term is adding this. Okay, so now what we will write here, we can write here kc0 x to the power k plus 1 plus, in bracket we can write here, we can see again here, kc1 plus kc0, kc1 plus kc0, and power we can again check here, x to the power ka, x to the power ka. Okay, and similarly if we next see here kc2 plus kc1 x to the power k minus 1 a square and so on, and at the last what we get here, you can see here, that is kc kx to the power k minus k a to the power k plus 1, kc k a to the power k minus 1 a to the power k plus 1. Now you can see here kc0 is 1, we can write this way. Now this can be changed here by kc k plus 1 c0. Okay, this can be write this way, it is also 1, it is also 1. Now it is x to the power k plus 1. Now this can be write as this way using the combination formula that you know, that is k plus 1 c1. If you don't know this point, you have to prove it separately, or you can search it in combination. Okay, so now we can write here k as, can be write here k plus 1 minus 1 and a to the power 1. So similarly you can write here k plus 1 c2, and this one can be written as x to the power k plus 1 minus 2, total is k minus 1. So you can write a square, and this way, and the last term you can write again kck as k plus 1 ck plus 1. The value of this is equal to this one. Okay, that is 1. Now a to the power x to the power k minus k. So here is, we can write here again k plus 1 minus k plus 1, and this is a to the power k plus 1. So student, we get here, now what we get here, right side, that is k plus 1 c0 x to the power k plus 1. Okay, now plus k plus 1 c1 x to the power k plus 1 minus 1 a to the power 1 plus k plus 1 c2 x to the power k plus 1 minus 2 a square, and so on, and the last term is k plus 1 ck plus 1 x to the power 0 a to the power k plus 1. Now it is true for sk plus 1. Hence by PMI we can say binomial theorem is true for n belongs to, for all n belongs to natural number. Okay, so student, this way you can prove the binomial theorem. Now student, I want to describe you what the formula I have used here. You have to prove it. Let ncr plus ncr minus 1 equal to n plus 1 cr. This we have used in above the binomial theorem. If this is r equal, this is greater than 1, this, then we can write here n plus 1 cr. So let LHS equal to, if you want to know detail, you have to go to the chapter combination. Okay, so we can write here factorial n upon factorial r factorial n minus r factorial n upon factorial r minus 1 factorial n minus r minus 1 Now we can write here factorial n upon r factorial r minus 1, and also we can write here this is n minus r minus plus n plus 1 r, so we can write here n minus r plus 1 factorial n minus r. Taking these steps common, what we get here? We get here factorial n upon factorial r minus 1 and factorial n minus r. We take the common, but we left here 1 upon r plus 1 upon n minus r plus 1. Okay, now take the LCM here. What we get here? We can take the LCM here. We can find r n minus r plus 1, n minus r plus 1 plus r. So what we get here? Factorial n. This r is cancelled. We get n plus 1. And this r can be written with this, and this value can be written with this. Okay. So again we can write here factorial n plus 1, and this can be written factorial r, and this can be written as factorial n minus r minus 1. So we can write here n plus 1 cr, and this we can written also n plus 1 factorial r factorial n plus 1 minus r. Okay, so we can write this formula, and it is equal to RHS. And one more formula I want to detail here: NCR equal to NC n minus r. So now RHS equal to factorial n upon factorial n minus r factorial n minus r factorial n upon factorial n minus r. N is cancelled out, it is r, so it is equal to NCR. Okay, so we can write here this RHS equal to this one. This is a very useful formula. Okay, if the sum of this is equal to this, then they are equal. Okay, now in Pascal, in a binomial theorem, we can check here x plus a square equal to x square plus 2xa plus 1a square. You can see this is equal. Okay, x plus a whole cube equal to 1x cube plus 3x square a plus 3x a square plus 1x cube. You can see this one is equal. This coefficient is equal. So in binomial theorem, if we expand this, when 4c0 x to the power 4 plus 4c1 x to the power 3 a plus 4c2 x square a square plus 4c3 x cube a plus a cube plus 4c4 a cube to the power 4. You can see value of this is equal to this, and value of this will be equal to this, and you can see here first this term equal to this one, second term from starting equal to second term from last, and this way this you can find the value of equal. So how you can see here. Okay, student, are you understanding? Now I am describing this again. Now in the expansion of x to the power n nc0 x to the power n minus 0 a to the power 0 plus nc1 x to the power n minus 1 a square, and you can see this is the first term and plus this is the second term. So what we get here, if we get here ncr x to the power n minus r a to the power r, this will be the which term? This is r plus 1th term. Okay, and this way you can see This one is the first term, second term, r plus 1 term, and that is the last term, ncn x to the power n minus n a to the power n. So what is this? This is known as general term. Okay, hence in expansion of x plus a to the power n, what is the value of general term? That is tr plus 1 equal to ncr. You can see here it is fifth term, that it is 4. Okay, n minus r a to the power r. So this is a very useful formula to find the directly third term, fourth term, fifth term, sixth term, okay, anytime. So it is from starting, okay. Now from end in expansion of x plus a to the power n, general term will be ncr a to the power n minus r x to the power r. This you have to change this power of this. Okay, so you can understand that you have to check this one. Okay, this you have to change it. So you can then find the general term in expansion of x plus to the power n from end. Okay, from end. This is a very important point. So student, this is a very important point. If you want to find third term from starting, use this formula. Third term from last, and you can use this formula, right? So now you can see here x plus a to the power 2 x square plus 2 x a plus a square. If here is 2, how many term is 1, 2, 3 term? How many term is there? 1, 2, 3 term. If here is 3, you can check here is a 3 term. So what is the formula I can say? That is x plus a to the power n. Number of terms n plus 1. Okay, number of terms n plus 1. If n is even, then n plus 1 is odd. Okay, if it is odd, then there will be 2 middle term. One is t n plus 1 upon 2th term, and other is the next term of this one, n plus 1 upon 2 plus 1th term. Okay, student. Now what happened if n is odd? Then n plus 1 is now student, if n is even, then n is odd. We should revise here. N is even, then n plus 1 is odd. Then if it is odd, then only one term middle. So we should write here n is odd first, then n plus 1 is even. Okay, then 2 middle term. If it is even, then 2 middle term. This one is even. Okay, now student, x plus a to the power n. If n is, in previous term we are taking odd, now n is even, number of term n plus 1, that will be odd. then one middle term, that is n plus 1 upon 2. If it is odd, then one middle term you will find. Okay, student. So now again, x plus a to the power n, number of term in expansion n plus 1. How you can find here n plus 1? Here is 2 term. Okay. This value we are getting here this way, that is equal to n plus 1 c1. The value of this is n plus 1. Okay, if here are 2 term. Now if you want to find the expansion of this, here are 3 term. Then if it is x, it is a. If it is x, it is a. First you have to express this, then again you have to define this. Then how will be term number of term? Then you can use the formula n plus 1 c2. Okay. So for example, let we start here a plus b plus c square. So we know a square plus b square plus c square plus 2ab plus 2bc plus 2ca. How many term? 1, 2, 3, 4, 5, 6 term. 6 term. If you use this formula, we can get here 3c2 factorial 3 into 2 upon 2 into we use here 1 plus 1 n plus 2 2 we can do it here 2 plus 2 c2 equal to 4 c2 4 into 3 upon 2 into 1, that is equal to 6. So increasing this one to Okay, also we can write this way formula. So student, now we can see using this topic we can expand and we can find the general term and from starting, and we can find the reducing term, general term from last, and also we can get some more values. You can check here. I will try to tell you. Now okay student, so I am going to tell you some interesting things. If we write the expansion of 1 plus x to the power n, what we have to write? nc0 1 to the power n minus 0 x to the power 0 plus nc1 1 to the power n minus 1 x to the power 1 plus and so on, and the general term ncr 1 to the power n minus r x to the power r plus ncn 1 to the power 0 x to the power n. So we should not write the value of this one, okay, because the value of this is 1, so we can write in this way: nc0 plus nc1x to the power 1 plus nc2 x square plus nc3 x cube and so on, ncn x to the power n. Okay, so if you want to be describe this, you have to learn this one. Okay student, so now if we put x equal to 1, what we get here? 1 plus 1 to the power n, nc0 plus nc1 plus nc2 1 square and so on, ncn x to the power 1 to the power n. So we get here 2 to the power n equal to nc0 plus 2c1 plus 2c2 dash 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 2 nc1 nc2 ncn. So this is a very useful formula. nc0 plus nc1 plus nc2 plus ncn, the sum is to the power n. Okay, so now since it is 1, so to the power n equal to 1 plus nc1 plus, and you can write this way, nc2 plus ncn. So sum of this will be to the power n minus 1. Okay student, now let we put x equal to minus 1. So we get 1 minus 1 to the power n, nc0 minus nc1 nc2 minus nc3 and so on. Okay, it is 0. So we can say sum of coefficient of, if we put here this one, nc1 plus nc2 nc3 nc5 dash 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 equal to nc0 plus nc2 nc4 dash dash dash. What we find here? We get we can say sum of the coefficient of even terms and sum of the coefficient of odd term. Sum of coefficient of even term is equal to sum of coefficient of odd term. Hence it is student, right? So student, using this formula we can say this will be half of total sum, and that is the total sum was to the power n, so we can get to the power n minus 1. Okay student, so now one more things I want to describe you, that is let we express this 1 plus x to the power n. C0 plus C1x. Now I am not writing here n. It is understand. Okay. This n you have to understood that we have write here n, so it is n. Plus C2x square dash 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 plus Cn x to the power n, and again we can write this way: C0 x to the power n plus C1 x to the power n minus 1. Now it is the 1. So okay, so this second term will be 1. So C2 x to the power n minus 2 dash 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 Cn x to the power Cn here is 1. Okay. Now in 1 into 2, if we multiplied 1 into 2, what we get here? We get here 1 plus x to the power n, x plus 1 to the power n, 1 plus x to the power 2n. So this will be expansion of 1 plus x to the power 2n, and we can see here if we multiply this one and this one, what we get here? C0 square x to the power n plus C1 square x to the power n minus 1 n plus C1 square C2 square x to the power n dash dash dash. Hence C0 square plus C1 square plus C2 square dash 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 is coefficient of x to the power n in expansion of 1 plus x to the power 2n. Okay. Similarly, if we want to find C0 C1, that is the coefficient of x to the power n minus 1. Similarly C0 C2, that is the coefficient of x to the power n minus 2. So this way, using this you can do more questions. Okay, so student, I am telling you for binomial theorem any index for next video. Binomial theorem for any index in next lecture. Okay, so you have to wait for same. Thank you for this lecture, this video. Learn this and go to the practice of questions from your book. Thank you.